Okay, in this video, I'm going to explain a couple of the 3D modeling techniques related to making your module. And I'm going to explain kind of some of the techniques that we use in Rhino to experiment with the design of that module. So first thing I'll do is open up a new Rhino window. I'm going to go into top view. I like to use top view, but work 3D. So, this is the first time in this class that we'll be working in 3D. So the way that we can go into 3D in like a orthographic view, like top view or front view, is if I hold Control Shift on the keyboard, right click on the mouse and drag. You'll see my little cursor turns into the orbit cursor. Now I'm in 3D. So like when I do anything in 3D, I can see it three-dimensionally, and so on and so forth. Real quick before I get too far, I also want to make sure I'm in the right units always. Down here at the bottom, you can see I'm in millimeters. I'll just type in units in the command line. Make sure my model units are set to inches. There's nothing in my file, but even if there was, I would just put yes. Okay. And so the assignment stipulates that we need to make a volume that's 3 by 3 by 6. So I'm gonna just make a box. I'm gonna do that using some of the solid modeling tools we have here at our disposal, which are underneath the little box icon here. You can also get to the command by just typing in box in the command line. And so I can click anywhere to start drawing my box, and then I can type in dimensions, which are 6 by 6 by 3. And that's in inches. So there's kind of the volume now. Actually, maybe what we should do is, so the large face of the volume is going to be like the face. That's going to be the side that faces out or in. So we can also draw it, 3 by 6 by 6, right? Like that. Because this is like that. That's kind of the open face. And the way we're going to tile it is like this, right? That's the side we want facing out. Like so. Work this way. Okay. So I'm going to show you guys a couple of techniques. There's a couple rules we want to make sure we pay attention to. So the size of the box. The other one we need to pay attention to is the volume. So if I just type in volume with that box selected, and keep in mind this will only work with closed joined polysurfaces, it'll tell me, my volume is 108 cubic inches. So pretty close to 100. We know that we need to subtract at least 30%, at most 70% of that volume. And so as I go through and start to subtract from this guy, that's how I'm going to keep track of that. I'm going to use the volume command. Now, just to reiterate, again, that only works on closed polysurfaces. So this thing right here that I've just drawn is what's called a polysurface, right? And if I draw a plane that's 6 by 3, that's just a single surface, right? And that's, well, actually it's an extrusion right now, but so if I wanted to make this into a box, I could use the command extrude surface and extrude it perpendicular to its face and make it whatever height I want. I want to make it 6. And I'll delete the original surface. Okay, so there's a closed volume polysurface. So just like a polyline, a polysurface, and if I explode it, you'll see what I mean. It's just a collection of individual faces that are joined together. And when we join a polysurface that has no openings, no edges, that's what's called a closed polysurface. And that's what allows Rhino to register that, yes, this thing is like a closed volume. And we can measure, how many cubic inches it has because it's volume. So just to kind of explain that a little bit. So primarily what we're going to do here is kind of try to model some kind of shape based on solid void, or what's called Boolean operations, Boolean subtractions, and so on. So for example, the one that you'll see in our lecture will be a cylinder, a series of cylinders that kind of intersect with the face of the volume, the faces of the volume. And there's a couple of ways. So, the basic technique we're going to do here is what is called a Boolean difference. And so if I select this volume, which is my tile, my original, kind of module, and type in Boolean difference, and then I select the cylinder or whatever geometry I've created. Again, that has to be also a closed polysurface. And press enter, you can see it'll like subtract that volume from the original volume. And again, we can, because we've done a solid, it's called a solid difference or a Boolean difference, we can still measure it. We still have a closed polysurface. We can still measure the volume. You can see here we've subtracted 15 or so cubic inches. So we need to do at least double that. Now, so that's basically what we're going to do. And in order to make this technique work, we need to make sure that our thing is going all the way through our object. So for example, if I do it like this, we're going to get this weird kind of shelf on one side. And so it's very simple. You just have to make sure it's going like past the object, right? Going all the way through. And the same is true if we create one that goes like through the middle of it. Again, if we do Boolean difference, select that polysurface, we can make a void through the surface. That's one of kind of the most basic techniques you'll use for modeling 3D geometries is Booleans. Makes a lot of sense for like, cutting a window out of a wall and stuff like that. There's a lot of other techniques you'll use as well, but anyway, this one is kind of, one of the basics. And so we can use really any type of these solid shapes to begin to subtract from this volume. Now, I'm going to show you a couple of kind of design techniques that go along with this. And in doing so, hopefully give you some inspiration for how you want to approach your project. So if I subtract like that, so we're left with something that's kind of rotationally symmetrical. And the idea, I think, that we're getting at a little bit with this module is that when we repeat it, something kind of else happens, like something, some kind of quality emerges from it. So one of the most kind of simple ways to do that is to, and I guess I must have lined this up wrong, so I've already messed up, but one of the simplest ways to do that is to, take whatever volume we're using to subtract with, for example, this sphere, and I'm putting it at every corner, right? And so again, Boolean difference, if I select all these spheres, and then I start to repeat this module, it's going to have a larger pattern that emerges when it meets at that corner. It's going to create the volume. It's going to create the partial volume of whatever we've subtracted from it, right? So that's one of the kind of simplest ways to think about subtracting from this volume. Now I will point out the other kind of purpose of this assignment will be to actually create voids that go through our object. And what do I mean by that? Basically, I mean, and I can get a center point. I'm going to get a center point of this volume. We'll click volume centroid, which will create a little point. That way I can copy this guy to the middle. Okay, so that's going all the way through our volume, like so. We could even actually, let me try something else. Put it at the midpoint of each of the edges of the box, like we did before. So then I go Boolean difference. And so now when I repeat this geometry, we get a void that goes all the way through like the surface of our wall. When I type in volume, I'm getting about 70, so that's about minus 40 cubic inches. So that's the right amount of kind of subtraction. It's on the lower side, but it's enough. And so we want to make sure we're making voids that go all the way through our wall, because part of the assignment is going to be to, have this thing kind of filter light, break up light as it's entering a space, right? That's the way this module is supposed to perform. Okay, so that's the basics. Now there's a lot of different modeling techniques. I think a lot of the things you'll want to play around with are in these solids right here. So I'll show you one other example, which is the truncated cone. And that allows me to draw basically two circles and change their volume dependently. Now, if I wanted to, change the size of the radius at either end dependently. So let's say I wanted to take this volume and again, repeat it in a way that is going to give me, like some kind of tiling pattern where the module repeats and like lines up with itself and so on and so forth. So I'm going to make a line, an axis around the center of my my volume at that center point that I made just a second ago. I'll click on both sides. Make a line. Doesn't really matter how long. We just need something to rotate around. And so instead of just copying this to every corner of my box, I'm going to start to rotate it in a precise way. I'm going to say rotate 3D. So the first thing it'll ask me for, so rotate 3D is like rotate, except that it doesn't assume that we want to rotate it in whatever plane we're drawing in, which in this case is X, Y. We want to rotate it around a specific axis. And that's going to be the line we just drew, like that. And now I want to make sure I hit the option copy. Okay, so I'll go back to shaded here. And then I'm going to do the same thing kind of on the other side. I'm going to, except this time I'm going to mirror it. And rotate 3D again around the center axis. Okay. And so this is kind of like one of those geometries that I think we saw in the first, again, that'll be in the lecture. Boolean difference. So I guess I am breaking one rule here, which is I don't have something that goes all the way through my geometry, but like, oops, let me copy that. So like with the other example, when I start to move this guy and repeat it, it's not going to happen as simply for me, right? And again, I'm hitting tab to constrain to a certain dimension when I move this. But I'm starting to get something where I can find certain alignments, right? I rotate this guy around. Again, then I have this kind of completed volume that starts to emerge from that. So we start to get these kind of synchronicities between, how the volume's lining up with itself. We're getting these kind of surfaces that are continuous from one geometry to the next. Anyway, so that's another technique, is to kind of mirror it. Go back. Use the mirror, use the rotate, repeat shapes, and kind of orient them around the edges of your objects. Now there's a couple other things I want to show you guys. Let's say we wanted to make a void from an ellipse. I'm actually going to go into front view now, so I can kind of draw in front view. Back. I've drawn that around that corner. I'm going to copy this to the other side. So rather than always using our solid difference, to make a, always using our solid modeling tool to make a surface. I can also use a couple other tools now, like I saw before, like I showed you before. I can extrude this, extrude curve. And that will allow me to change any closed outline into an extruded closed volume. Just like that. Again, when I do that, extrude curve, the option solid is set to yes. When I set the option solid to no, oops, you can see I just get an open tube, right? Which is not what I want. I want it to automatically close my object. make it a closed volume. Now, if I have an open volume, sometimes I can fix that as long as the openings are planar openings, planar edges. So like this outline is kind of on a plane. I can use the command cap, and that will automatically create surfaces at those planar openings and kind of join it all together. And again, if I use the volume command, you can see that I have a closed volume. Okay, now there's another way that I can make a surface. Let's say I have these two curves that I want to kind of create a surface between the two. So I'll select both these outlines, and I'll type in the command loft. And when I loft it, I'll get this options dialog to show up. I'm going to set it to normal, which it should be on by default. I'm going to set it to do not simplify, and I'll click OK. And so what it's going to do is create a polysurface that's kind of like stretched between one outline and the other. And again, because both outlines or both openings are planar, I can type in cap, and it'll create those closed outlines. And then I could even use rotate 3D. Do my Boolean difference. And there you go. You can see we have, oops, we have a geometry that should be able to line up somehow. Not exactly sure where that alignment would be, but it should be in there somewhere. Anyway, so we have a geometry there that can start to line up. And then one other technique I want to show you guys. A little bit different than the loft is going to be to do something called a sweep. I'm going to draw a, so I'm going to make this a little small. And I'm going to kind of move it through my volume. Now this is going to be one of the more advanced techniques to actually, keep in mind you want to actually make this into a physical model. So just be mindful of, using kind of weird dimensions and making it in a way where it's hard to figure out how to physically model it. But anyway, so I'm going to use the spline tool, aka interp curves. Again, that's the thing that'll allow us to draw freeform curves. Now, I started at the center of my outline, so I got the center snap turned on. It'll ask me where's my first point. I'm going to snap to the center of my ellipse there. And now I'm holding Alt to not snap to anything in my object. I'm just going to draw it all the way through, just a pretty simple curve like that. And I could even start to, if I go to wireframe again, I could start to turn the control points on for this guy. I'm going to manipulate this curve just a little bit so it kind of weaves through my surface. Simplify just, there we go. Okay, now I'm going to use a command called sweep 1. So I'll type in sweep 1. Actually, make sure I have nothing selected first, because it's important the order in which we select our outlines for this. So sweep 1. First, it'll ask me for a rail curve. Basically, sweep is going to kind of like extrude an object along a path or a rail. The rail in this case is that line I just drew that kind of goes through the object from one face to the other. And then obviously this outline is my cross-section curve. And I can drag the seam point again because I only have one outline. It's not a huge deal. And there we go. So now I have a couple options in here. I can pretty much leave them default. And again, we have a shape that doesn't have a closed outline. We could select it and go cap. It would create some closed outlines. Now, the other thing that you just need to be mindful of with this guy is when you sweep something of a certain size, it can actually kind of intersect itself, which is what had happened just there. I don't know if you guys noticed that. You just type in that one more time. But depending on the size and orientation of the rail curve, or sorry, the cross-section curve, sweep one. See what's happening right there is it's like intersecting itself. Same thing down there. So we want to kind of try to avoid that, because that'll give us messy geometry. One of the ways to do that would just be to like fuss with this line a little bit until we get it figured out. And again, the more we can kind of simplify, the better off we'll be. That. We want to just make kind of smooth transitions. Okay. Not sure if we totally got it, but anyway, I'm just going to try and do this. So cap, select the outline, Boolean difference. There we go. So now we get this kind of volume. Not sure we wanted that to happen, but anyway, we get this kind of volume where the cutout moves from one side of the geometry to the other. Now, the other thing I want to explain is that the other technique here for kind of creating this geometry is, we're going to be making a physical prototype kind of based on whatever form you model. And so, I want you guys to try a few different things with your 3D modeling. But once you kind of get something figured out that you're interested in making, then the key really becomes, okay, well, how do I make it? How do I figure out like how to make this shape out of a cast object? And so essentially what we're doing here is we're making a 3D model in a way where it corresponds to like a prototyping or modeling, physical modeling technique. So for example, if I go and do a cylinder here, the way I would actually model this, basically a box with a kind of hole through it, which is pretty boring, but the way I would actually model that is I must have moved my box. A second here. Okay. Okay, whatever. The way I would actually model this is by creating a box that represents the outside volume of the tile of the module, and I would create, some kind of void using some other material that I would then place within that volume to create the cutout. All the way to the end. And in order to, figure out what that volume would be, like again, all we need to do is build a kind of simple box to pour our plaster in to represent the volume. But, if we wanted to, I'm going to copy this real quick. If we wanted to represent okay, how am I going to figure out what that shape is and what I need to like model in order to pour a plaster cast that looks like that? Then I need to figure out what these volumes are when they intersect the, the box that I'm going to use to cast my plaster in. In order to do that, we just use a different Boolean operation. And I'm going to use Boolean intersection. And it'll ask me the first set of polysurfaces, that's my box. Press enter, and then these cutouts are my second set. And so that right there, assuming I still have my box, I can do that real quick. Hold on. Boolean intersection. Boom. Sorry, there's a way to do it where you keep both, I think. Whatever, we'll just copy it to clipboard so we can paste it back in later. Boolean intersection. Okay. Let's say that's our box, you know. That's what our kind of volume is going to look like when we pour into it. And this is what we need to actually fabricate, either through layering up of styrofoam and then carving, cutting and sanding, or through kind of a similar process using the wax. So one of those two techniques, either with foam or wax, we're going to fabricate a box to pour plaster in, and we're going to fabricate these kind of shapes to insert into our box, and that's going to create the kind of right conditions to cast this shape out of plaster. And the beauty of using either case, the wax or the foam, is that we can kind of destroy it to get it apart. So like you might imagine that this thing, well, if it were a sphere, for example, it would kind of be like encased plaster. So how do we get that thing that we use to make that void? How do we get that material out? Well, we can cut it. We can melt it if we need to, with the wax, for example, and we can kind of work it out. So even though it might be something that plaster is poured all the way around, we can still kind of figure out how to cut it out of the shape. That makes sense. And again, like I would actually model this by figuring out for myself, okay, I'm going to need a cylinder of a certain size. I'm going to cut a plane down from one edge, a certain distance of plane at a certain angle here and here, and just kind of figure out all these cuts that I would need to make in order to fabricate this kind of shape, and then use it to create a cutout from. Now, going back, the other thing I wanted to say, and I'll cover this more in depth in a separate tutorial, is that one of the things that you'll want to, that is one of the deliverables for our assignment, is to make a diagram of the process by which you modeled whatever shape it is you end up kind of landing on, doing for your prototype. So one of the things that's really good to do while you're going along and modeling this, and once you figured out what shape you want, is I'm going to kind of save every step, basically. So for example, let's say I modeled a cylinder in a box like so. I'm going to make a copy of it. And so then let's say I rotated it. And then I'm going to make a copy of that. And then let's say I rotated this guy around that central axis. Great. And then I'm going to make a copy of that, right? Before I do my Boolean difference. Because what we want to do later on, and this will be, again, a separate tutorial, is to kind of create a frame by frame diagram representing how we kind of modeled these geometries and why they create a modular pattern of print. So basically, at this point, what you'll want to do is just keep in mind, model every step and then make a copy. And you'll want to save that in your file, and I'll show you how to make a nice diagram later on. Okay, so that's going to end this tutorial.